Welcome back, students. This is part 2 of our lesson on half-angle identities. In this part, we're going to derive the identities that you're learning. There will be 5 of them. I don't know the notes number off the top of my head, so you'll just have to look that up and fill it in. And as usual, you don't have to write down the part where we're deriving the identity. You can just write the identity down when we get to it. Okay, here we go. So half-angle identities are tied closely to double-angle identities since half and double are inverses. So here's one of our double-angle identities that we learned last time. Now I decided to replace 2 theta with theta, and if I do that, I just have to replace theta with theta over 2. Because as long as what you have in here is twice what you have over here, see theta is twice theta over 2, then it's still true. So what I'm going to do is take the equation right here and isolate sine of theta over 2. And theta over 2 is going to represent a half angle, half of theta. Okay, so looking at the equation, let's subtract 1 from both sides. So now we have cosine of theta minus 1 equals negative 2 sine squared theta, or sine squared theta over 2. I'll switch colors because that color isn't showing up so well. Now let's divide both sides by negative 2. So we have cosine of theta minus 1 divided by negative 2 equals sine squared of theta over 2. By the way, we can simplify our fraction on the left side of the equation if we multiply the top and bottom by negative 1. And that's going to give us 1 minus cosine of theta over positive 2. So that looks a little bit better. Okay, the next step is to square root both sides. Now maybe I'd like to rearrange it first, so I'm going to put sine squared of theta over 2 on the left and 1 minus cosine theta over 2 on the right. Square root both sides. Don't forget about plus or minus when we square root. Okay, so there's our identity. Now notice that it has a plus and a minus sign in front of it. When we actually do a problem that has specific numbers, we're going to figure out whether to use the plus or the minus. It'll be one or the other, depending on the quadrant. So that is our half-angle identity for sine. You can write that on your card. Okay, here's an example. We can find the sine of 15 degrees using a half-angle identity because 15 degrees is half of one we know how to work with, half of 30. So 30 is going to be our angle theta that's here in the identity. We're going to use 30 for theta. Okay, now 15 degrees is in quadrant 1. And in quadrant 1, sine is positive. So if we're thinking about whether to use the plus or minus sign, we're going to use the plus for positive value. So we have the square root, the positive square root of 1 minus cosine 30 over 2. Now let's use a reference triangle to find the cosine of 30. We'll have a 1 on the opposite, a square root 3 on the adjacent, and a 2 on the hypotenuse. So the cosine of 30 is square root 3 over 2. So now we have the square root of 1 minus square root 3 over 2 over 2. Wow. So that needs to be simplified. So how about if inside the radical we multiply by 2 over 2. Distribute the 2 in the numerator. All of this is inside the radical. Now we have 2 minus square root 3 as our numerator and 4 as our denominator. Now we can break up this radical into the square root of the top, square root of 2 minus square root 3, over the square root of the bottom, square root 4, and we know square root 4 is 2. So this is our answer for the sine of 15, the square root of 2 minus square root 3 over 2. And this might be the first time you've ever seen a square root inside a square root. That looks a little weird. I would go ahead and put that in my calculator and then put sine of 15 in my calculator and make sure that they have the same decimal approximation. Number 2, the sine of 112.5 degrees. So that is half of 225. So this is the sine of 225 over 2. It's half of one we know how to work with, so we use a half angle identity. And 112.5 is in quadrant 2, and sine is positive in quadrant 2. So once again, we're going to use a positive square root. So we have the square root of 1 minus cosine of 225 over 2. Now let's make a reference triangle for 225, quadrant 3. That'll be a 45, 45, 90. So -1, -1, and 2. Oh, square root 2. So the cosine of 225 is negative square root 2 over 2. So we plug that in and simplify. So right now we have the square root of 1 plus square root 2 over 2 over 2. And just like we did with the last problem, let's multiply the numerator by 2 and the denominator by 2 inside the fraction, or inside the radical, I mean. And that is going to give us, let's separate it into the top and the bottom radical. The top is the square root of 2 plus square root 2. The bottom is square root 4, which is just regular old 2. So that's a lot of 2's and a lot of square roots. Square root 2 plus square root 2 over 2. I would put that in the calculator as well and check it. Okay, back to deriving the rest of the identities. We're going to take a different one of the cosine double angle identities, and notice that I've already replaced my 2 theta with theta and replaced my theta with theta over 2. So remember, as long as what you have in here is double what you have over here, it's still true. So just like we saw before, the goal now is going to be to take this equation and isolate the cosine of theta over 2. So the first thing we'll do is add 1 to both sides. And we can rewrite the left as 1 plus cosine theta, and we can switch sides so the left is the right and the right is the left. And then divide by 2 on both sides. And then square root. So this looks a lot like the previous identity. The cosine half angle identity and the sine half angle identity are almost the same. The cosine has a plus and the sine has a minus in it inside the radical. Okay, so let's try an example. Let's find the cosine of pi over 8 radians. We know pi over 4 radians is 45 degrees, so we're talking about finding the cosine of 22.5 degrees. So that's half of 45. So we'll use our half angle identity for cosine. 22.5 degrees is in quadrant 1, and cosine is positive in quadrant 1, so we're not going to need a negative. We're going to use the positive in front of the radical. So far we haven't done one that had a negative in front, but we always check. So we have the square root of 1 plus cosine 45 over 2. Cosine 45 is square root 2 over 2, so 1 plus square root 2 over 2 over 2. And just like we did on the others, multiply by 2, top and bottom. So now we have the square root. Well, I'll make my square root sign smaller. I'll separate the top and the bottom. The top, square root of 2 plus square root 2. The bottom, 2. The answer is exactly the same as the answer we got for the last problem. That has to do with cofunction identities. The sine of an angle is the cosine of 90 minus the angle. Something like that. So we did the sine of 112.5. That would be equal to the cosine of 90 minus 112.5. That's actually cosine of negative 22.5. But then we have even and odd identities, and cosine is an even function. The cosine of negative 22.5 is equal to the cosine of positive 22.5. So that was interesting. We got to use those other identities that are on the card that we hardly ever use just to justify this answer and why it's the same as the last problem's answer. Okay, the next problem is cosine 105. By the way, there are other ways we could do this problem, like 105 is 60 plus 45, and we could use an angle sum identity. So now that we have so many identities, there's multiple ways to do a lot of the problems. But we're going to practice using the half angle identity. And 105 is half of 210. And 105 is in quadrant 2. And cosine is negative in quadrant 2. So finally, we're going to use a negative in front of our radical. Negative square root of 1 plus cosine of 210 over 2. Okay, so we need a reference triangle for 210. That would be quadrant 3, 30-degree reference angle. Okay, so we have negative square root of 1 plus the cosine of 210 is negative square root 3 over 2. And that's all over 2. Now we do our 2 over 2 thing and our split it into two radicals thing. So we have negative square root of 2 minus square root 3 all over 2. And you can check that on your calculator. Okay, the next thing is to do the tangent half angle identity, and it has 3 variations. But this video is getting long, so I'm going to make a part 3 video and we'll finish the lesson there. Thank you.